Hey, this is Mr. Aiden. This is the 2021 AP Calculus AB exam. This is free response number 3. If you don't know me, go to MrAiden.com or my YouTube channel, Mr. Aiden, and it's a one-stop shop for all chemistry, physics, and calculus needs for students and teachers. But let's get to this question number 3. This question number 3 was, I think, one of the most creative questions they've done in probably 10 years. My students did have some problems with it. They did the best they could, but they had a tough time kind of visualizing what this whole question was about. And I think that's a big part of it, is just visualizing what happened. My students said they were able to set up things. They weren't able to totally get to the solutions. Some of my students were able to get to the solutions for this problem, but a lot of them just set a lot of them up and tried to get as many points as possible because it was a rather creative, difficult question. I think it's an absolutely great question, though. You can see it says a company designs spinning toys. Okay, and the first thing I thought of when it said the company designs spinning toys is things that look like this, like a spinning top or something like that. And what they were doing is they were taking the spinning top and cutting it right through the axis and making it horizontal. And so you kind of had to think of this spinning top this way. And they gave you this family of function, okay? And so this family of function is y equals c, which is some constant c, x times the square root of 4 minus x squared, and of course this is y is equal to 0. Okay, so we had two different functions here, and so a lot of my students knew what they were doing. They knew they were revolving around an x-axis. They knew they were revolving this guy this way around the x-axis. They were just a little bit not sure of what it looked like in real life. Okay, and so the first one says is find the area. My students had no problems with this. They were just trying to find the area of the bound of these functions. And so what we did is we took the area is equal to the integral from, we want to know from here to here. So we want to set this y is equal to cx square root of 4 minus x squared. We want to set this equal to 0, okay, to find out these 2 points. Obviously, we have x is equal to 0, and we have x is equal to plus or minus 2. In this case, it's going to be plus 2. So we have x is equal to 2, and x is equal to 0. Those are your bounds. You're going to get some points for those bounds, which is nice. And what are we going to do? We're going to go from 0 to 2. These are our bounds. And our c is obviously 6. And then we have x square root of 4 minus x squared dx, which means it's 6. We can bring this 6 outside. 0 to 2 of x, so the square root of 4 minus x squared dx, and right away you can see we need some u substitution. And so we're going to make this u is equal to the 4 minus x squared, which means we want to find what du is equal to, which is negative 2x dx, negative 2x dx, which means negative 1/2 du is equal to x dx. And what do you know? I have x right here. I have dx, which that substitutes in for that. And so I have to do some u substitution here. Okay, so we still have the 6 out front. We have the negative 1/2 times negative 1/2. And we are going to substitute x dx. X dx is going to be your du. And we have our u to the 1/2 power, because the 4 minus x squared was our u. It was square rooted, so u to the 1/2 power. One last thing is I have to change my bounds. Always think about it. You have to change your bounds when you do u substitution. So we got to plug 0 in for x, 4 minus 0. So when x is equal to 0, u is equal to 4. And we also need to plug in 2. So when I plug in 2, 4 minus 2 squared, when x is equal to 2, u is equal to 0, which means my values are going to be from 4 to 0. And now I can do my integration. Integration celebration. And so 6 times negative 1/2 is negative 3. Let's do our integration. That u to the 1/2 goes up to u to the 3/2. I'm going to multiply by 2/3, the reciprocal out front. And I'm going to do this all from 4 to 0. Okay, and so let's finish this bad boy out. We get -3, and we're going to plug in 0 first. We get 0 minus 2/3 4 to the 3/2 power. Okay, and so I got to do this 4 to the 3/2 power. What's 4 to the 1/2 power? That's 2. 2 to the 3rd power is 8. Okay, so again, how I did that. 4 to the 1/2 power, the fractional power is 2. 2 to the 3rd power is 8. So 8 times 2 is 16. So I have -3 times -16/3. And that cancels the 3's out, and I end up getting +16, which is my area. Okay. A difficult question A, you can see where we need to find out our limits of integration. We set up our integral. We got to do u substitution, change our limits of integration in terms of u, and we find out our area is +16. Now we go to B. B says it is known that for this function that the derivative, and they gave us the derivative of this function, for a particular spinning toy, the radius is at the largest cross-section is 1.2 inches. So that means right here is the largest radius. So that is going to be 1.2 inches right there. And we want to know what the value of C is, And so let's think about this in terms of, we know we're at some y value right here, or some x value right here. We're at some y value. We know what the y value is. It's 1.2 because that's a 1.2 inch radius. Okay, so we're some x distance away to give you this 1.2. Now we also know that the slope of the line, which is the rise over the run, okay, the rise over the run, for this exact point right here, the slope is equal to 0, isn't it? The dy over dx is equal to 0 for this exact point, because that's where the maximum point is. That's the maximum point. And what do we know, according to the first derivative rule, is when we hit max points, the derivative is going to be equal to 0. Okay, and so what do I know is I can say, when does this equal to 0? When does the dy over dx equal to 0? Well, that means I have to set this value right here, this 4 minus 2x squared equal to 0. And I got to do a little bit of algebra. I take over the 4 right here. I have -2x squared equals -4. I divide by -2, so x squared equals 2, which means x is equal to square root of 2, plus or minus square root of 2. So I know that this x value right here is going to be the square root of 2. Now, what am I going to do? I want to find out what the c value is. I know y in this function right here. Okay, so I'm going to use a different color. I'm going to use purple here. In this function right here, I know y equals cx, the square root of 4 minus x squared. I know y is 1.2. I don't know what c, that's what I'm trying to find. I know x is the square root of 2. I know the square root of 4 minus the square root of 2 squared. So let's think about what this is. We have 4 minus 2 is 2. So we have the square root of 2. So we have c times the square root of 2 times the square root of 2, which is equal to 2c. Which now I divide by 2, and that means c is 0.6. C is 0.6. That was a really difficult problem. You really have to think outside the box here. And you can see we had to do a bunch of different steps. One thing, we had to understand that this was a maximum value, that this y value was 1.2. That's critical to it. We know, no pun intended, the critical point, the max is equal to 0. When the derivative is equal to 0, we set that numerator equal to 0, and we solved. Really cool part B. Now part C, we know the volume. The volume is 2 pi cubic inches, and we want to know what C is. So what do we think about volume? Volume is equal to pi from 0 to 2, because those are my limits of integration, of my function. What's my function is cx, the square root of 4 minus x squared, squared. dx. And that volume is equal to 2 pi. And so let's think about this. Logically, what happens here is this is really, believe it or not, is this function, this y is equal to cx, the square root of 4 minus x squared, minus y equals 0, but I don't need to do that, but I need to do that squared. This is the equation for the volume as we rotate it about this x-axis here. Okay, so let's think about what's going on here. Is we have, I need to square everything in here. I need to divide the pi on this side. So we have the integral from 0 to 2 of c squared times x squared times 4 minus x squared dx. And that's equal to 2 because I divided the pi on that side. So let's keep going. We're going to bring the c squared because that's a constant equals, and let's distribute this. We have 4x squared minus x to the 4th power dx, and that's equal to c squared. And I think we're doing pretty good so far. We're going to, let's see what we're going to do here, is we want to figure out what this integral is right here. Okay, let's figure out what this integral is right there. And so the integral from 0 to 2 of 4x squared minus x to the 4th dx. This is 4/3 x to the 3rd minus 1/5 x to the 5th, and we're going from 0 to 2. Okay, double checking that I have everything correct. I think I do. Now let's plug in 2. So we plug in 2 and we get 2 to the 3rd, it's 8. 8 times 4, that's 32 over 3. Minus 2 to the 5th. 2 to the 5th is 32 divided by 5. 32 divided by 5. Minus 0. Everything's 0. So now I need to get some common denominators. I need to do a little bit of algebra here, or a little bit of mathematics, and I end up getting 160 over 15 minus 96 over 15, which ends up becoming 64 over 15, which is beautiful. So now I can come back to this problem right here, okay? And what do I know is, I know this whole integral is 64 over 15, isn't it? I know I have c squared, and this is equal to, I put a c squared here, the c squared's not supposed to be there, it's supposed to be a 2, okay? And so this is equal to 2. And so what do I need to do? I need to do the reciprocal on this side. So I have c squared is equal to, let's see, 30 over 64 because of the 15 times 2 is 30, divided by 64. Now I'm going to take the square root, and so the c ends up becoming the square root of 30 over 8. The square root of 30 over 8. And that's what our c is in order to give us this volume of 2 pi. Again, a lot of my students were able to, all of them were able to set it up, be able to kind of get through it a little bit, and it is just a pretty arduous task in order to get to that c squared. So again, one of the more creative, really cool, outside the box thinking problems. This is the 2021 free response number 3.